Hi guys, hey, this is Mr. Crumrine. How you doing? Let's talk about the Pythagorean theorem. But first, I want to test your knowledge to see if you can figure out this little example. Let's try it. Take a few minutes to solve for C. As you can see, C is 7.2. And you're asking, how did we do that? Well, don't be discouraged, and if you did get it right, great job. But let's talk about it, and let's go into what we know about it. First, the Pythagorean theorem is one of the best-known mathematical theorems, which provides us with relationship between the sides in the right triangle. A right triangle consists of two legs, a hypotenuse, and the two legs meet at a 90-degree angle. The hypotenuse is the longest side of the right angle, and is the side opposite of the right angle. Also, guys, there's a link right there below if you'd like to click on it to read more about the Pythagorean theorem, and it has another short video. Let's talk about the terms about the Pythagorean theorem. First is the hypotenuse, which we just described right here. It's always the longest side of your right triangle, and it is always in the c squared department. A right triangle is a type of triangle that has a one angle that measures 90 degrees, right here. That significantly shows 90 degrees. And it has two legs, A and B. And that's where you get your formula right here. It's A squared plus B squared equals C squared. Why do we use the Pythagorean theorem? Many positions or careers are used when managing the use of Pythagorean theorem regularly. All these careers need this formula in the day-to-day profession of their corresponding fields. Computer and information system management, construction managers, engineer, and natural science managers. In engineering, you can build cars, buildings, and even technological devices like your cell phone or the computer you're on. Computer engineering, cloud computing, compile design, computer architectures, computer networks, database, data structures, design and analysis, and even distributed computing systems. The best one I thought was, and most exciting and very interesting, is the Pythagorean theorem is used for two-dimensional navigation. GPS, we all have them on our phones and even in our cars. It's the distance between north and west with the two legs of the triangle and the shortest line connecting with them being the diagonal. The same principles can be used for air navigation, like when you're going on a plane. That's when a pilot figures out how he's going to land from one spot to the other. Here's a short video and fun video, a Justin Bieber remix that I know you guys will really enjoy, and it's to help you remember the Pythagorean theorem.
Here's the formula. A squared plus B squared is C squared. A squared plus B squared is C squared. A squared plus B squared is C squared. Pythagorean theorem. A squared plus B squared is C squared. A squared plus B squared is C squared. A squared plus B squared is C squared. Pythagorean theorem.
I know about you guys, but that was really cool. I hope you guys were dancing too. Let's talk about the Pythagorean formula. A squared plus B squared equals C squared, where A and B can be interchangeable in the formula. As you can see right here, no matter what, you have to add them together to equal C squared. And C is always placed in the equal department, where it says C squared, which remember, C is always the hypotenuse and is always the longest angle. Another way to see the formula is this way. A nice visual. Think of the size of blocks, and each side is a block connected to each side of the right triangle. Each block relates to the length of each side. As you see, each block is a different size, which relates to each of the sides' different lengths. As you can see, guys, each of the blocks are different sizes. The biggest block is always going to be the C, as you can see. C squared. And as you guys know, in the next video that's going to show you, you can actually take these two blocks Put them together, and it's going to equal this size of a block. Pretty cool, huh? Now let's watch the video.
What do Euclid, 12-year-old Einstein, and American President James Garfield have in common? They all came up with elegant proofs for the famous Pythagorean theorem, the rule that says for a right triangle, the square of one side plus the square of the other side is equal to the square of the hypotenuse. In other words, a squared plus b squared equals c squared. This statement is one of the most fundamental rules of geometry and the basis for practical applications like constructing stable buildings and triangulating GPS coordinates. The theorem is named for Pythagoras, a Greek philosopher and mathematician in the 6th century BC, but it was known more than 1,000 years earlier. A Babylonian tablet from around 1800 BC lists 15 sets of numbers that satisfy the theorem. Some historians speculate that ancient Egyptian surveyors used one such set of numbers, 3, 4, 5, to make square corners. The theory is that surveyors could stretch a knotted rope with 12 equal segments to form a triangle with sides of length 3, 4, and 5. According to the converse of the Pythagorean theorem, that has to make a right triangle, and therefore a square corner. And the earliest known Indian mathematical texts, written between 800 and 600 BC, state that a rope stretched across the diagonal of a square produces a square twice as large as the original one. That relationship can be derived from the Pythagorean theorem. But how do we know that the theorem is true for every right triangle on a flat surface, not just the ones these mathematicians and surveyors knew about? Because we can prove it. Proofs use existing mathematical rules and logic to demonstrate that a theorem must hold true all the time. One classic proof, often attributed to Pythagoras himself, uses a strategy called proof by rearrangement. Take 4 identical right triangles with side lengths A and B and hypotenuse length C. Arrange them so that their hypotenuses form a tilted square. The area of that square is C squared. Now rearrange the triangles into 2 rectangles, leaving smaller squares on either side. The areas of those squares are A squared and B squared. Here's the key. The total area of the figure didn't change, and the areas of the triangles didn't change. So the empty space in one, C squared, must be equal to the empty space in the other, A squared plus B squared. Another proof comes from a fellow Greek mathematician, Euclid, and was also stumbled upon almost 2,000 years later by 12-year-old Einstein. This proof divides one right triangle into 2 others and uses the principle that if the corresponding angles of 2 triangles are the same, the ratio of their sides is the same too. So for these 3 similar triangles, you can write these expressions for their sides. Next, rearrange the terms. And finally, add the 2 equations together and simplify to get AB squared plus AC squared equals BC squared, or A squared plus B squared equals C squared. Here's one that uses tessellation, a repeating geometric pattern, for a more visual proof. Can you see how it works? Pause the video if you'd like some time to think about it. Here's the answer. The dark gray square is A squared, and the light gray one is B squared. The one outlined in blue is C squared. Each blue outlined square contains the pieces of exactly 1 dark and 1 light gray square, proving the Pythagorean theorem again. And if you'd really like to convince yourself, you could build the turntable with 3 square boxes of equal depth connected to each other around a right triangle. If you fill the largest square with water and spin the turntable, the water from the large square will perfectly fill the 2 smaller ones. The Pythagorean theorem has more than 350 proofs, and counting, ranging from brilliant to obscure. Can you add your own to the mix? Did you enjoy this lesson? If so, please consider supporting.
Alright guys, wasn't that a pretty cool video? I really like the ending part. So let's go to problem 1. It says find A, B, and C and put the numbers in the formula. As you can see, that 6 and 8 are available, and that is our A and B form. So we're going to use our formula and then start putting our numbers into our place. 6 squared, which is 6 times 6, 8 squared, which is 8 times 8, equals C squared, which comes out to 36 plus 64, which equals 100, which that comes out to, what is the square root of 100? 10. That's right. Let's go to problem 2. Now we see that we have one leg available at 8 and 12 is available, which is our hypotenuse. Let's take a look at it. Let's break it down. Let's use our formula, put our numbers in. Let's see how it is. It says 64 plus b squared equals 144. So what we have to do is bring the 64 over and subtract it from the 144, and that comes out to 80. And now there's not an exact number for the square root of 80, so we have to give our best rounding number, which is 8.9. And that's okay. Not every number is going to be a perfect round number. Let's go to problem C. We have our hypotenuse shown here again, and one of our legs, 5. Let's break it down. Let's look at our formula, place our numbers in. We have a squared plus 25 equals 169. Again, we have to get the number by itself, and so we're going to subtract 25 on both sides, and we're going to get 144. What is the square root of 144? That's right, that's 12. That's a lot easier. That's nicer when it's round like that, isn't it? Alright guys, I know that we went through there. If you guys have any questions about the Pythagorean theorem, you can always ask through my video chat through Teams. You can phone call me, by message me, and email it, and we can make that best available on your time, my email, or instant message me through Teams and Remind. I hope you guys learned a lot today, and I can't wait to hear from you guys. And here's all the resources and videos that we watched today if you want to go back and look at them. All right, guys, have a great day. Bye.